Hello everyone. Welcome to Special TV. A few years ago, the Q3 group transported 107 heavy wind turbine foundation piles, called monopiles, through Eemshaven, the offshore port of the Netherlands. These monopiles were intended for 2 wind farms in the North Sea. We also see the placement of the special SPMT transport structure.
The Eemshaven is the largest port in northern Netherlands. It is also known as the offshore port of the Netherlands. During the period from 2023 to 2024, numerous special transports of large steel monopiles will be carried out there. The duration of the project was influenced by various factors, with the weather conditions playing the biggest role. The transportation of the monopiles took place via water, making the project heavily dependent on the weather. Monopiles are steel foundations used for offshore wind farms. These specific monopiles were intended for wind farms code Wind 3 and Borkum-Riffgrund 3. Wind farm code Wind 3 is located about 32 kilometers from the island of Noorderney in the North Sea. While Borkum-Riffgrund 3 is situated at about 53 kilometers from the island of Borkum. Once these wind farms are completed, they are estimated to provide energy for about 1,200,000 households in Germany. The energy group Ørsted is the client for the 2 wind farms, namely Code Wind 3 and Borkum-Riffgrund 3. With the realization of Riffgrund 3, Ørsted is creating the largest wind farm in Germany. The transport and installation of the monopiles, over and on the water, were carried out by the Belgian company Jan de Nul. The monopiles have a length of approximately 90 meters and a diameter ranging from 9 to 9.5 meters at the widest, while the narrowest side has a diameter of 7 meters. Ørsted is the client for the construction of those 2 wind farms. They had the steel monopiles made with steel from Dreiling, the parent company of Steelwind, which manufactures the monopiles. These monopiles are made without transition pieces, so the wind turbines can be placed directly on them. The monopiles were transported from the Steelwind production facility in Noorderney, Germany, by barge and with the help of tugboats to the Eemshaven. The Eemshaven covers an area of 1,324 hectares, which corresponds to 13.24 square kilometers, and has a depth of 14 meters, with a total quay length of 5,120 meters. At the bow terminal Eemshaven, the monopiles were unloaded at the quay and temporarily placed on a sand elevation. The bow terminal covers an area of 210,000 square meters and has a quay length of 694 meters. The heavy transport activities were carried out by the Q3 group on behalf of the owner of the bow terminal. From the storage area at the bow terminal, the monopiles were transported to the quay of the Juliana Haven. This transport took place via the Westblok, followed by a route over the railway and the Eemshavenweg to the Juliana Card. The transports to the Juliana Haven were essential, as the most advanced installation vessel from Jan de Nul was used for the construction of the wind farms. De l'Olysée has a depth of 9 meters, which meant that Jan de Nul's crane installation vessel could not dock in the Beatrixhaven. In contrast to the Beatrixhaven, the Juliana Haven has a depth of 11 meters. And a quay length of 2,300 meters, making it suitable as a loading dock for the monopiles. For the safe and controlled transport of monopiles, with an average weight of 1,500 tons, SPMTs were used. These vehicles that are specially designed for heavy transport and special transport, and are also known as self-propelled modular transporters. By constructing modularly with different SPMTs, which had multiple axle lines, these could be placed under the monopiles. This ensured that the weight of the monopiles was evenly distributed, allowing them to be transported horizontally, without excessively loading or damaging the roadway. The choice for this transport solution, based on coupled SPMTs, is the result of a close collaboration between the operational and engineering teams within the Q3 group. This highlights the commitment and expertise that were present within the organization. The experienced team of the Q3 group has been intensively engaged in an internal process of critical analysis, design and optimization for these transports. Their findings have led to an effective solution. The calculation takes into account the weight difference in the construction of the monopiles at the front and rear, as well as the varying centers of gravity of the monopiles, which have been carefully assessed for this transport. After the calculations, the Q3 group decided to use a combination of 66 axle lines and 12 axle lines for the secondary beam components. The configurations of the SPMTs consisted of 3x10, 3x12, and 2x6 axle lines. There were several reasons for the choice of SPMTs. One important reason is that only a limited pressure may be exerted on the road surface. Furthermore, given the variety and dimensions and weights of the monopiles, using SPMTs provided the greatest safety. According to the Q3 group, there were alternative transport options available with different equipment. However, in this specific case, the SPMTs were the safest option for transport. Various SPMT configurations were possible for these transports. The Q3 group, however, always focuses on the safest solution. Therefore, after extensive calculations and sharing experiences within the Q3 team, this final configuration was established. In total, the Q3 group has carried out 107 heavy transports of monopiles using Cometto SPMTs. At that time, the Q3 group only had transport equipment from the brand Cometto, which significantly facilitated the management of their projects as well as maintenance and service. In addition to the monopiles, there were also other projects for the Q3 group in Eemshaven-Groningen. These projects included components for the construction which were essential for the development of the wind farms, Borkum Riffgrund 3 and Gode Wind 3, with the transport activities taking place on behalf of Daar Terminal in Eemshaven. Cometto, the developer and manufacturer of SPMTs, maintains a strong relationship with the Q3 Group, partly because the Q3 Group has 78 axle lines in a long-term lease contract with Cometto. The need for the development of SPMTs has arisen from the demands of Cometto's customers. As a manufacturer, they have been challenged by the market in the past, which is electronically controlled and can drive autonomously. Nowadays, it would no longer be possible to meet these requirements without this technology. The SPMTs used by the Q3 Group for its transport projects are in use under a long-term lease agreement with their partner Cometto. Through this leasing arrangement, the Q3 Group has a total of 78 axle lines. They could use them for multiple projects, as they had done in the Eemshaven. The Q3 Group had chosen Cometto as a partner for the supply of SPMT axle lines. Because Cometto was able to provide equipment quickly for the Q3 project in the Eemshaven by delivering their products. Additionally, Cometto also offers excellent service and reliability. At the time of this project, the Q3 Group only had equipment from Cometto, which made it simple for the projects to be executed, and for the corresponding maintenance of the equipment. In Part 1 of the monopile transport, Part 2 follows with a report on the transport. From the transport combination back to the setup at the Bow terminal in Eemshaven, and the placement under the next monopiles to be transported. After the monopiles were placed in the Juliana harbour, or directly loaded onto the offshore installation vessel of Jan de Nul from Belgium, the transport combination had to be driven back for the second transport that evening or for the first transport the next day. It also happened that there was a considerable amount of time between the different transports. This was due to the weather conditions making a new supply of monopiles impossible. The monopiles were transported over water from Germany. The first transport was carried out the next day around 6 in the evening, and a part of the port was closed for that. People could still reach their workplace in the port or leave the port via a detour. The coupled SPMT construction followed the same route back to the storage area of Bow Terminal. However, the SPMT construction had to be carefully maneuvered, first to place it under the next monopiles for transport. This was not easy as it had already become dark. But it was good to see that the employees of the Q3 group had already done it regularly, based on how the placement was carried out. The SPMT structure was easily placed under the monopiles, which rested on a sand bed with a wooden structure on top. The SPMT construction was carefully placed under the monopiles. This setup was certainly precise, as the monopiles had a weight difference along the length of the entire steel structure. In addition, the SPMT structure was also designed to absorb more pressure from the monopiles in certain areas. This was distributed through the SPMTs to the ground. In addition, not many support points were placed under the monopiles, and their placement was indeed precise. These transport saddles, developed internally by the Q3 group, were hydraulically pressed against the monopiles, safely connecting the monopiles to the SPMTs. After the first saddles were placed against the monopiles, the system was locked. After the first NP transport saddle was secured, the Q3 workers continued connecting the other saddles to the monopiles. After various connections between the monopiles and the SPMTs had been established, the heavy iron monopiles were raised so that they could be detached from the wooden structure that lay on top of the sand bed, and on which the monopiles rested. The lifting of the monopiles was done hydraulically by raising all the axles of the SPMTs. Once the monopiles were raised to transport height, the removal of the temporary support legs began. And then the first meters of a new transport followed. But now only to the entrance of the storage facility. From where the next evening it will be transported to the Juliana Haven.